Okay, so just about to start the panel, and the panel is called Hindrances to Socially Beneficial Technology. And on the panel, we have Colin Klein, an engineer, James Newton-Thomas, who is speaking later on today, and also Greg Adamson, who has just spoken to you about the hindrances to socially beneficial technology. So this is going to be a continuation. We'll let the panel members speak for a while and pass topics around the table. Then we'll allow for some questions to be asked from the audience. Okay, so first of all, would you like to introduce yourself and have a comment on the topic? Colin Klein.
Thanks, Adam. Yes, I'm an engineer. I have been a professional engineer since about 1960. So if you're looking at a long view of technology and society, then I guess I've got it. I don't know what I've got the wisdom. That's a different kettle of fish, as they say. Benefits to society, or hindrances to benefits to society, risk to society, all these words. This is going to sound rather strange from an engineer. I would turn to philosophy straight away. Let's define the words. Let's know what we're talking about first. Like Wittgenstein, very keen on language. It doesn't necessarily reveal truth. If you don't know what you're talking about, you don't know what you're talking about. Wittgenstein famously said, there are no problems in philosophy except if language takes a holiday. And fellas, look at those things. And yesterday we had Robert Sparrow spoken about, let's analyse the benefits to society, or define the word benefits, and in published that was cool. And he went off into the humanities and a bit of philosophy, and I quite agree with him that you can't measure the benefits to society by dollars only, or by population growth only, or by technical excellence, or by lifespan of the product, or by how legal clear it is. Perhaps all of these measures apply, but they're very qualitative. And if we're going to be an engineer, and I doubt many of you want to be, we want to have not just a qualitative estimate of it, we want to is not qualitative only, but we need a quantitative estimate. Sometimes we're dealing with very rubbery figures, don't they? But to say that it can never be quantified in some measure, the measure may be by popular survey, that's valid. Survey the population here on a scale from 1 to 10, what do you think is the benefit of it? Is it objective? No, but we're dealing with a subjective quality. Was this good to you and your family? It's rated on a scale of 10. Stick it in the figures. Do your stats. Get a measure of the benefit to society by popular survey. That's quite valid. Maybe society could be constrained by cultural constraints, the mood of the day, the Weltanschauung, the zeitgeist, whatever. Can't escape that. Whatever era you're in, whatever culture you're in, you're constrained by those things. So I was saying that benefits, and if you like hindrances too, can be measured qualitatively and quantitatively if you just set up the stats right. Have I gone too far, folks?
All right, hindrances to technological introduction. First, any questions on
No, we're going to have questions after you've sort of passed it around, I think. Yeah.
Oh, I'll throw in a few horror stories on the introduction of technology. Why is technology not introduced? I'll show you one, a personal experience. This is a Cybernaut heads-up display gadget, which you stick on your head, and this connects here. I bought this thing for about $4,000, thought I'd do the whole Chris Mann thing and become a Cybernaut. And totally ugly, just cannot use it. The silly twiddler doesn't work properly, the mouse. It works, but it's just, the learning curve is too long, the thing's ugly, the cable gets caught up every time you turn your head. So ugliness is a big thing, right? Ugliness is one reason. But on a more practical bent, on a more serious bent, in the mining industry we have a lot of problems. It's a tough industry. The mining industry is harsh, it kills, you're dealing with big machines, you're dealing with explosives, it's filled with testosterone, filled with poisonous gases. And it's a very dangerous industry to work in. So you'd think that automation is a fairly obvious thing to put into the mining industry. And at Caterpillar, we spent over $60 million automating trucks, which we successfully did. But now, if you have an operator, let's say he's had a bit of an LSD binge a couple of nights before, and I'll just say something quickly on that. In the mining industry, they introduced drug testing policies, right? So, unfortunately, the drug testing can pick up marijuana for 6 weeks after a person's had it. So therefore, all the miners went off marijuana and started taking LSD. LSD only lasts for 24 hours or something like that before it started deploying. In fact, they had this big charity bash, flying ambulance service, and to raise money up to Boxing, I think it was. And they had about 5 ODs. There was actually more money lost having to fly out these guys with IOD at the charity function. Anyway, all I'm saying is things have unexpected and unintended consequences. So you get some guy doing back-to-back shifts, right? He's working 12 hours, his circadian rhythm's all out because he's going underground at say 6 o'clock in the morning. The sun hasn't come up and he's coming up at 7 o'clock and the sun's already gone down. And he does that for a whole week. His circadian rhythm is completely shot. He then goes on to a night shift. Right, so it's a back-to-back shift. He does 1 week on day shift, 1 week night shift, and then he goes away. They fly him out for a week. He does his second week, and let's say during that second week he's feeling tired. He may have had a bit of a binge sometime in the past. He's got through the drug testing, but he's not feeling that with it. He takes his 40-ton truck out onto the drive, runs over a whoopee, kills 2 people. Terrible situation. Happens. And it does happen. And what they do, of course, they'll bring in all these occupational health and safety people to send on these things, and you run accident analysis boards, and everyone goes in there and they say, terrible thing, how can we stop this? How can we prevent this? What can we do? The driver is punished, the operators are punished, the procedures are changed. One way, of course, is you can automate the vehicles. Just say, all right, we'll automate the vehicle. And we can, work we've done, we can lessen the chance of such accidents by something like 500–600%, right? By simply automating the vehicles. But we can show that we have now a vastly less chance of killing anyone. But do you think we can get those machines into the mines? The answer is no. We could give those machines to the mines. But the insurance costs of putting those machines in will cost more than human operators. Right? It's something you don't expect will come up to bite you. The insurance costs, and worse, with AI systems that we use that have to evolve, because in the mining industry the machines are always changing, they're always, bits are breaking, they're ripping their wheels, their hydraulics start to leak, the things start to wear, change over time. So the systems are inherently adaptive. They are constantly adapting. They are learning to control themselves. And so you have an issue with accountability, because people come along and they say, oh, that machine's done something wrong. Whose fault is it? They want to be able to go back to the manufacturer. They don't want to say, oh, well, the machine's done this because you taught it badly. You put it in this right. You, in the way that you have been using this machine, you have taught it a kind of behaviour which it is now manifesting, which has caused you a problem. Accountability becomes a big issue because people have an issue, a difficulty in trying to give accountability to a non-conscious entity like a machine. So they want to then fall back on us. But of course, we can't take responsibility for a machine that's been trained for 2 or 3 years in a mining environment. Anyway, so there's just 2 aspects. One, insurance, a real killer. Lawyers and insurance as a real handicap to getting things into any industry. And as I say, at Caterpillar, we spent $60 million automating trucks. And to this day, except for maybe 1 or 2 mines around the world, and they're not ours, there's no automated trucks on the surface. We were able to do it underground because you're 2 kilometres in a tunnel and the machine can't get out, it can't cause any damage. But that, although we managed to, 20 years before DARPA, before Desert Challenge, managed to get viable and operating trucks, autonomous vehicles, could never deploy them. Could never deploy them, despite the fact that they would have saved lives and saved money. Well, they would have saved money in terms of production if we didn't have to pay the insurance premiums.
Now, I spoke at length, so I don't need to introduce. I just will throw in one point here. The declining rate of invention. There's a fair bit of literature on this on the internet at the moment. The earliest reference that I found there was in the American Journal of Sociology, which was A.B. Stafford writing in 1952, and the article is called "Is the Rate of Invention Declining?" Since then, so that's quite a few of the later researchers refer back to that original work and say, yes, this has been vindicated.
I'll jump in on that too. I'm going to show a slide on that during my talk, but a chap named Hubner out of Pentagon Naval Office, he has done extensive work on this. You can't really ignore it. He's shown that the actual major period of innovation was about the 1890s, 1900s, when people like Einstein were doing all their work, and Thomas Edison, people like that, late 1800s. But it's been declining since, and he gives several reasons for that, which I'm actually going to cover in my talk.
Questions?
Here you go.
I live in
Can you
China.
speak up?
I live in China, so I don't have any problems with IPR, intellectual property rights. So I literally 24/7 download scientific papers and books, and it's changed my life. Believe me, I just have infinite knowledge, and I suspect so many other Chinese researchers in the same position. And when you have effectively infinite, if you want to know something about a particular topic, you go to email.com. Okay. You type in the search window the topic you want and 50 books. And you can just hold down the button and scan down. It takes about 20 seconds to order 50 books. Okay. And 2007, 2008, very modern books. So personally, I now feel vindictive. I feel at war with the paper, underline, paper publishers. I feel they should die.
All right, well, I think it was Warren Buffett who said that digital technology has destroyed more industry than Karl Marx. For that very reason, and that touches on creative destruction. But of course the argument is that they need to make some profit in order to print those books. And I think we all understand that.
I'll pay a penny. I'll pay a penny for an electronic book. But why should any Chinese student, or why could anyone for that matter, pay $50 for a paper book when they can get it virtually free electronically? So it's an outdated technology that should die.
If I could
And
just
then
add
to everybody's benefit.
If I could just add to that Warren Buffett comment, one of my favourite quotes from Warren Buffett, in fact my favourite quote from Warren Buffett, is his comment on the internet where he said, for humanity, the internet is positive, but for capitalism it's a net negative. Which I think, I like that a lot because it's a very clear explanation that economic interests and social interests are not necessarily aligned.
Yeah, look, I've had quite a lot of experience with the internet over a long period of time. In 1989, I obtained code from a Canadian which allows me to print 3 of 9 barcodes, which subsequently led to me introducing systems that save something in the order of £450 million over a period of 15 years. I'm sorry. I then worked as the head of technology development for a multinational firm. I ended up over in Colorado Springs and sitting in this room, and every time I asked a question, this fellow Jeff Downs, who was a brilliant chappie, would simply go out on the internet and pull down all of these answers. I now work developing software with a group of very talented people, and we just scream through stuff that used to take us years to develop. And that's why I asked that question about the metric of, how do you come to this conclusion that innovation is slowing? What I believe is that innovation is on an exponentially escalating path, but you don't appreciate it. You become immune or you're desensitised to it. But every now and again I have to stop and grab myself and think, holy mackerel, if we'd been doing this 5 years ago, it would have taken us days, weeks, months, and we're doing it in minutes. We're on the, I just look at this and as a person who's been around now for 40 years doing this sort of stuff, I'm just getting more and more excited.
Well, I think you're correct in terms of IT. There's no doubt that it is exploding. But if you look at the range of innovation, where's my jetpack?
New Zealand,
Where's my flying car? Where are it? And that's the problem. That yes, innovation in one area, IT, is exploding. There's no doubt about it. But of course it doesn't reflect in patents as much. And so therefore it doesn't show. The data, if you look at the patents, is actually declining. I'll show that graph during the talk. But Huber's hypothesis is correct in a way. It is correct, but it is correct for most domains, except for a relative few. But those relative few are very important, and one of them is, of course, AI and the internet and software development, which you're involved in.
Just if I can continue on, I'm not only software development. I've built the world's largest trommel suspension system based around urethane. I've held patents on non-volatile memory circuitry. I've dealt in mechanical engineering, electrical engineering, civil engineering, a wide range. I have a nephew who has developed a means by which inorganic chemicals can be placed into organic molecules to defeat breast cancer. I don't think you've got an idea of the effect that this access to information has on the ability for us now to innovate across a total spectrum. I'm not just talking about IT. IT is most probably the greatest enabler of this. But in the world that I live in, the innovations are just, well, they're gobsmacked. They're beyond the ability for us to soak them up. That's most probably one of the things about it. So I put a different view. That's why I asked about, by what metric do you come to the conclusion that people are being less innovative? I watch people on their iPhones and they're doing all sorts of innovation and they don't even appreciate that they're innovative, but they are innovative.
Cameron Riley mentioned before that hyperlinks subvert hierarchies, and perhaps that's an answer to one of the comments that was made, or Hugo Gauss was mentioning that you could get access to pretty much any information for free instead of going through commercial channels.
Well, last speaker from Williams spoke about the enabling effects of IT. I agree, IT does do that. Please, let's define the words carefully. I'm a great definer here. Pedantic like all get out. Downloading stuff, no matter how much, how quickly, is not innovation. What rises from it might be innovation, but don't confuse the two.
You mentioned before about the mining industry being the biggest block ahead with insurance. Do you think there might actually be more opposition with the fact of humans losing jobs to automation systems, such as you see in production lines at the Ford factory, with replacing workers with robotic arms?
Yes, obviously. I'll give you another example, a bit of a horror story. When we were putting systems in around the world, we had some inquiries from some mines in South Africa. And of course we thought, why on earth would the South Africans want automation systems? Because they have so much effectively cheap labour. And the answer is that the population, the labour force is dying. the mines actually brought in prostitutes for the workers in the mines, and they now all have HIV. So, and there's a terrible thing. Now that's generally you will not undercut the price of a human with an automation system. The humans are, such a general functioning entity. They can do more than one task. They are multitaskable, whereas your automation systems are focused on one narrow job. A human can jump in and drive a vehicle. They can also pick up something. They can also control a type of machine. That multi-skilling, which is of course pioneered by the Japanese, that multi-skilling is what makes a human such a valuable element of the workforce, and it will be a long time before we can undercut that.
But do you not say that there be any issues with sudden spike in unemployment as the cause of all the industrial?
Sorry, if you could just make it a bit louder.
Yep, so do you not think that there be issues with the sudden spike in unemployment from these the lower income workforces that are unable to actually go into other areas? Or?
A spike in unemployment.
Oh, look, ultimately, as sort of a singularity believer, I think we're all going to be unemployed. I think the government should be worrying less about, about employing people and how to gracefully unemploy people and how to keep them happy and productive in another way, whether it be art or somehow give value. But ultimately, I mean, look at this. We've got our muscles were replaced 200 years ago by steam engines, and effectively, and you don't see many of us sort of doing that kind of labour anymore. And our brains are going to be replaced in the next few decades. So what are we going to do? So no, I think unemployment is ultimately inevitable from this, and that of course one of the big social problems.
Yeah, so actually just one more quick thing. Are you looking to sell that Cybernaut device with that?
Okay, any other questions?
Absolutely. Come find me later.
If I could just quickly add to James, he says ultimately we will all be unemployed. Let me run on your parade, guys. I'm the ultimate catastrophist. If we don't do something about climate catastrophe, we'll all be dead before we're unemployed.
Yeah, look, on this, if you remember, Barry Jones wrote a big book, Sleeper's Wake, and he showed these nice pyramids, and they were all being eaten up from below from the technology. But of course, they got it wrong. What happened was that technology is employed to do things that we are good at. So suddenly you got all these spreadsheets and functions that were aimed at middle management, which kind of cut a swath through the middle of that pyramid. That technology, for economic reasons, is always targeted at what we are, it pays the most, right? What pays the most, which is effectively things that we are not very good at. That is boring, repetitive operation. Of course, we make mistakes, so therefore the first computers were put into that type of job. In fact, the word computer used to be an occupation. It used to be a guy who sat at a desk counting up numbers all day for astronomical ephemeris. Now, technology is employed deliberately to do things that we are bad at, or where it's unacceptable to employ people, so war and things of that nature. So, unfortunately, of course, AI, or general AI, it will be able to do the things that we are good at, and it'll be able to do them better than us. And that's where we really see a paradigm shift and a problem, a social problem occurring. Global warming.
Can I try to put the argument on its head? Why is it necessarily a bad thing if our technology slows down? Why is hindrances to technology something we should try to avoid? Isn't a lot of the problems we're facing at the moment, including climate change, due to technologies like the chainsaw, which we just have no idea what the ultimate effect of it would be. And by slowing down technological advance, apart from the fact that I do not have to try to work out how Vista works, and as soon as I work it out, somebody comes up with some other idiot system which I have to work out, but also from the fact that maybe we should do things slower and therefore try to see if we can work it out. So how do we actually put roadblocks into the pace of technology to make it at a more human pace?
Okay, this is a philosophical question, and I think if we go back to the original philosophical discussion of, the original discussion of philosophy and technology, not philosophy and science, we look at the crime that was committed by Prometheus. And the crime that he committed was not to provide fire to the humans, for the gods. So he was imprisoned on a rock and had to spend his forever in exile. But the crime that he committed was he caused humans to lose their to lose their lack of confidence around what they could do technically. So we're looking thousands of years ago now. This question was raised: how do we limit our imaginations? And I think the answer is we can't. There is no path backwards. I don't think there's any way that we could undertake a program of slower technological development apart from the ways we've seen it happen historically, which is the collapse of great civilizations. And I don't think I'm not aware of any evidence that anybody deliberately caused those civilizations to collapse.
Let me endorse Greg. Trying to slow development, innovation, technological development, it's like trying to filter.
It's like trying to filter the internet. You can't.
Now let's just take Prometheus a little bit further. If you remember Prometheus, he used to wander about the earth collecting all of the ills that befell mankind. And he put them in a box, which was being looked after by his wife. And everyone knows the name of his wife, Pandora. So when Prometheus was strung up on the Caucasus, the thing eating his liver, his wife opened the box, of course, being curious, see what's in the inheritance for her, opened the box and they all flew out and escaped back into the wild, out of our control, except for one which she slammed the lid on. Does anyone know what that one is?
Hope.
Hope. Hope. Right? And that was the moral of the story. That we always have hope that the world will come out in a nice way.
Yeah, Colin mentioned yesterday Stu Kaufman's At Home in the Universe. I think it speaks a lot to this space of innovation. He's actually done some pretty hard research with mathematical models on the pace of innovation in a complex fitness landscape and what the basic rule is, and you go back to things like the Cambrian explosion. When a new territory opens up, and again this frontier suggestion comes out, the most efficient way to improve your status is to jump all over the place and try and land on a high mountain. But once you're on a reasonably high mountain, that process loses its gain factor, and what you do then is work incrementally. So it is possible when you're looking at a fine-grained view of innovation to say, yeah, there's vast amounts more innovation going on now. But when you look at major moves of platform, innovation naturally slows. So the coming up with platforms on which you can innovate, and probably until we get off planet, there's not a lot. The internet's been one, but until we get off planet, there's probably not major innovation. There will be some found, but the rate of finding a new territory in which we can just jump all over it and find great spots will always naturally slow down in a crowded frontier-free landscape. And I think if you have a look at Kaufman's work in that, you'll get an understanding. It's a logical model that does work across all kinds of fields.
I'll just add something to that too. Tony was saying, that it's very interesting, although that was, that theory was put forward, a lot of mathematics went into that. It's interesting, nature actually discovered that itself. If you look at biological systems under stress, the population collapses. As the population gets smaller, you get inbreeding within the population, which then causes greater mutation, which effectively does the same thing that Tony just described, that you start to see a much wider diversity of genetic experiment, if you like, and thus you're more likely to find a way out of the problem that's causing population collapse. As it did happen actually to the human race, we got down to, they think, about 100 individuals at one stage, edge of darkness.
I just wanted to make a couple of comments about the internet itself. I was originally thinking of adding an extra category, but I decided not to do it. The internet, if you think back to 1989, 1990, there was nobody, there were no voices that said the internet was the future. There were no voices. So if you look at, True Names and Other Dangers. In True Names and Other Dangers, and which was about, it was 87 or something like that.
84.
84. Okay. So by 84, Werner Vinch was also already seeing the internet as a legacy network. So if you look at, from a data communications perspective, if you look at True Names, it's the internet is simply one of various. We have a network of networks rather than an internet as we have it today. If you go to 1994, if you look at the state of the art in 94, every corporation was expecting and investing in the information superhighway. And this wasn't the internet. This was something that was going to be based on a synchronous transfer mode for the commercial environment, for governments. It was going to be OSI based. Within corporations, you still have other elements. But it was only in 1995 that it actually became clear to industry outside of the communications industry that the internet was a meaningful thing. That was when Bill Gates cottoned on. That was when Netscape was floated and rapidly escalated. Around 88, 89, 90, 91, everybody, as far as I've seen, the universal literature was the internet showed the promise of the future. The expectation was that TCP/IP was not going to be the protocol that would be around in 20 years' time, which is, of course, what happened. In the same way that nobody expected CSMACD to survive. You know, I mean, how could you possibly be talking about gigabit Ethernet? That was just like, in 92, 93, people would have been considered crazy if they talked in that way. So the internet broke through that. The internet superseded the ATM-based information superhighway in the early 90s because of particular economic, technical and regulatory situations. The internet was possible because it did not require any approval. There was no internet receiver industry which needed to be approved by a government. There was no internet spectrum allocation which needed to be approved by a government. All you had was the rule that the FCC had said data was not to be charged differentially to anything else going over local telephone networks in the United States. And they declared that in the 1980s after the computer inquiries. So the internet sort of like wiggled its way through into success. It was not anybody's investment plan that led to this successful internet. And when you look at Tim Berners-Lee's original requirements for the World Wide Web, there's a category there that said that he was using a template, and there's a category there that says what isn't required in the invention you're inventing, or in the initiative you're proposing. This is its own. And he said the two requirements that weren't necessary were intellectual property and security, explicitly excluded from the original design of the World Wide Web. And so while we talk about the things that the internet has been able to achieve, and I completely agree with that, and I've worked with the internet since '91, and the things that it's been able to achieve are just marvellous. That was an accident. That was not the mainstream way that things are developed. And the internet was the first communication medium in 200 years. The first communication medium since the invention of the steam engine where mass uptake occurred before commercialisation of the technology.
The purpose of the session is to talk about social benefits or hindrances. James has mentioned a book by Barry Jones, our hero minister. He's my hero too. In that book called Sleeper's Wake, and he's up to about edition 5 now, he says many things, and if I summarise them all for you now, I bore you more than I normally do. Let me just focus on one thing, and employment has arisen here, several questions about it, from young people, quite properly so. You're worried about how I'm going to be employed, how am I going to feed myself, or possibly a family in the future. This is what Barry Jones had to say about work. He said 100 years ago, 60 to 70% of our population was employed in producing foodstuffs for the family and for sale. Nowadays, with combined harvesters, etc., 4 to 5% of our population produces all the foodstuffs necessary for consumption by Australia and for export. That will continue in other areas of employment, says Barry Jones. Eventually, only 4 to 5% of our population will be in work. What do we do with the other 95 and 96%? Asked Barry a rhetorical question. And he says, at that stage or before, work will no longer be a right, it will be a privilege. Once you have graduated in your first course, you will be allowed to work for 1 year, X years, X months. After that, you are no longer allowed to produce anything of economic worth. You can have hobbies, but you must not produce anything that's consumable. You can go back to university, you can take up a hobby, you can do anything, pole dancing if you like, but you must not produce. If you graduate again, you're entitled to 1 more year of work. But you see, the problem is, when 5% are producing everything, they've got the money. What are the other 95% to do? Currently, we just put them on the dole budget act, don't we? What we should do, says Barry Jones, is give them a social wage so they can consume, otherwise that 5% will be unemployed. It's radical. Read the book.
I have a question to the panel. Earlier, Hugo mentioned that the access to information is unprecedented, and the gentleman up here also made a comment about that. But what's being missed is that even though we have all this access to vast amounts of information, the ability to assimilate this information has not improved. I mean, in a sense, we are the bottleneck in the whole system. So even though we have this huge, vast data pool we can just draw on at a click, to extract anything of value from it, to extract wisdom from it, that hasn't increased. And I'm wondering if the panel has anything to say about that.
I think that's correct. There are some things that it is considered that possibly are just too complex for human understanding. One example is the human immune system. A few people talk about that as something that's such an incredibly complex system with so many interleaved that it may not be possible for a single human being to understand it. And if it is all so interconnected, then it means it is not possible to have human understanding of it. But that doesn't mean we can't have a machine understand it. And therein is your AI singularity, or at least the beginning of it.
Can machines assimilate knowledge for us? Yes, I have a brother-in-law who works in Perth, the Department of Human Services. It has absorbed all the previous laws and adjudications about child services and family services. And when the judge makes a new ruling, he has a screen on his desk and he asks the expert system, not an AI, expert system to compare his ruling to all the previous rulings for the past 20 years. And it flags when he has made anomalous decisions, incongruent decisions, or unfair decisions. There's a machine assimilating and advising a judge.
Okay. Just to let everybody know, we now have pizza outside. And it's been there. I've been keeping secret for a while because it's been so interesting.
but unfortunately we're running out of time. So I'm hoping we can all get back in the room at 1:30 for James Newton Thomas's talk.